All right, to finish off this section, what we want to do is talk about integrals like these three right here. These kind of integrals are quite important when it comes to something called Fourier analysis, right? And this is used in all sorts of applications, right? You see this a lot in quantum mechanics. You see it if you do signals analysis. It's basically a way to take a function and break it into a bunch of waves. So, and that relies on, at its sort of very core, the reason the theory works is because of how these integrals here work out. All right? So, in order to do these, we're going to need some trig identities. And it's based off of these two right here, right? The sum and difference formula. So, as you can see, sort of these parts over here kind of show up here. So what we do is we take some combinations of these that allow us to attack stuff like this. And the combinations we need are for sine-sine, sine-cosine, and cosine-cosine. Right? So by doing those, by combining them in these ways here, we can get a formula for sine times sine, cosine times cosine, and sine times cosine. Right? And they show up in this way. Right? So deriving these isn't really the important part or interesting part. I'll let you check that these do, in fact, work out. But basically, all we need to know is that, well, we can do these integrals up here by applying these formula. Right? So let's look at the integral of sine mx cosine, or sorry, I meant sine nx. So, oh, sorry. Right. So let's look at that. All right. So according to our integral formulas, we turn this into 1/2. Right. In this case, related to those identities, this is A and this is B. Right. So if you look back at that one, we're doing this one up top. So we're going to have cosine, now mx plus nx, and then minus cosine mx minus nx dx. All right. So I'm going to pull out that 1/2, and let's simplify our integrals a little bit here, because that looks a bit hard to deal with, but it really isn't. This is m plus nx minus cosine oops, that's supposed to be an m minus nx. Right, so we're just simplifying a little bit here. All right. So integrate this, so we get 1/2 sine m plus n x over m plus n minus sine again m minus nx over m minus n. All right, plus c. Now, one thing I do want to point out here, though, this is true. This one right here is specifically for m not equal to n. Okay? If m were equal to n, then we would be back in that earlier scenario. All right? So the other two go very similar to this, so I'll let you sort of work out how these other two here go. But yeah, that's basically how these all end up working out at the end of the day.